Hi guys, welcome back to the channel. My name is Zahir, and if you're new to this particular channel, I talk about AI, I talk about adaptability in careers, and also talk about some interesting tech stories. Today, we'll be talking about Parent Document Retrieval. This is part of the advanced track series, and in this particular video as well, we will be using the fictitious company as an example, that is TechnoHealth Solutions. We'll see how TechnoHealth Solution will implement the parent document retrieval to solve some of its use cases. All right, with that, let's get started. Like the previous one, we'll be using the 5 Ws and 1 H technique to explain the concept. We'll start with why parent document retrieval. We'll then look at what is parent document retrieval, when and where can parent document retrieval be implemented, who will benefit from parent document retrieval or PDR, and finally we'll see how PDR can be implemented using LangChain. All right. Before we begin, I want to talk about some of the questions that you see on the screen and why these are important considerations, or why these are important questions for you when you're trying to build a RAG-based solution. When you're trying to build a RAG-based solution, and you're trying to build this indexing pipeline, one of the things that you'll probably spend a lot of time thinking is what is the most optimal chunk size so that you get absolutely precise answer or high quality responses from the LLM. So the question is, what type of queries will the system handle? Are the queries typically seeking specific details? Do the queries require a broader contextual understanding, right? The second question is, how much detail or noise is acceptable in the retrieved result? Meaning that will smaller chunks provide too little context, or will larger chunks introduce too much irrelevant information? So this is something that you'll have to take into consideration as well. And what is the nature of the content being used for? Does the content lend itself better with smaller chunks? And does it require larger chunks to capture essential relationship? For example, take a legal document into consideration. Now, if you had basically chunked a particular document into smaller chunks, maybe there is a possibility that certain details are missing because you've essentially not maintained the relationship. However, if you had either chunked that into larger documents or passed that entire document, the quality of answers is going to be much better, right? All right, now we've established why we need parent document retrieval, because we know that there is certain inefficiencies in naive RAG technique where the smaller chunks might lead to loss of details or missing details, and larger chunk probably will add a lot of noise. We'll probably have to balance that. To balance is where the parent document retrieval comes in. Now, the parent document retrieval or PDR overcomes the inefficiencies of standard RAG systems that rely on smaller chunks, meaning that instead of just depending on smaller chunks, the PDR technique essentially passes larger documents to an LLM. How does it do that? I'll quickly explain that to you. Let's take into consideration this particular document that you're seeing on screen. Let's assume that it's a larger document with several pages. And the first thing that we'll probably do is we will essentially chunk this particular or this large document into larger chunks or larger docs. Let's call them parent doc. The reason we are calling it parent doc is because in the subsequent step, we will further chunk this large document into child documents or smaller documents. So let me explain again. This is a large doc. We split this into larger chunks, and we split each large chunk into several smaller chunks. All right. Now, here's some similarity with a naive RAG solution. We take these smaller chunks and essentially push it through an embedding model to convert them into their vector representation and store that into a vector database here. This embedding model could be any of the embedding models. In this case, I'll be using OpenAI's embedding model. And once the user queries, the same embedding model is used to turn the query into its vector representation, and then we do a similarity search on the vector database. The vector database, what is stored in the vector database is the child docs or smaller chunks. However, what is sent or what is retrieved from the what is retrieved for the large language model is the larger chunk, meaning in certain cases only the large document is sent to the LLM, and in certain cases both the smaller chunk and the relevant larger chunk is sent, meaning that if based on the query certain child docs will be retrieved, because child docs is what are stored, converted into their vector representation and stored into the vector database. When the query comes in, the relevant child doc is picked. However, the corresponding larger document or the parent document is sent to the LLM here, and the LLM has rich context of the for the particular query, and the LLM generates a response, and the response goes back to the user. I'll do a quick code walkthrough and you'll probably be able to understand this in detail. Now let's quickly check where can parent document retrieval be applied or PDR be applied. The easiest example that you can think of is customer support, because you want to enhance automated systems to provide detailed response on comprehensive product documentation. For example, let's say that there is a product company which has built a bot, and all the documentation is embedded and stored in the vector database, so that any question related to how a specific workflow needs to be executed or how a specific step needs to be executed, all of that can be easily answered by the bot. And so those steps could be much larger, and there could be several relationship between each segment in the documentation. So larger chunk or sending that entire parent document or larger chunks of the parent document to an LLM makes a lot of sense here. Research and academia, again, because you want deeper context, you want to essentially be able to send full research papers or articles in certain scenarios or larger sections of those particular research articles to an LLM, and and expect high quality responses. Same with legal and compliance. Legal and compliance especially have a lot of related segments, and sending larger chunks or sending the entire document in certain scenarios as context makes sense. Content generation, again, for content generation, the more content or the more context the LLM has, the better the quality of the content that is generated, right? Let's move on to the next section. When should parent document retrieval be used? Again, you can use this particular technique when you are dealing with complex queries or multifaceted queries requiring detailed context. You can also use this when you have lengthy documents that need to be segmented and need to be segmented for better comprehension. This needs to be, you can also use this technique to ensure high accuracy and relevancy in responses generated by language models. And if the user is seeking comprehensive answers rather than brief snippets, like I said, instead of one word answer, if you want to add more context to the answer, in that particular scenario, this parent document retrieval technique can be used, because the LLM has much larger context, while the smaller chunks help in retrieval, but sending the larger entire chunk or the larger chunk essentially helps in better quality responses. Who benefits from parent document retrieval? Like we discussed earlier, businesses or organizations seeking efficient customer support solutions can enhance their automated systems with PDR, and research and academics, individuals needing thorough literature reviews or data analysis can utilize PDR for effective information retrieval. All right, with that, let's actually see how PDR is implemented in LangChain. I'll go to the document now. All right, what you're seeing on the screen is a Collab notebook, and most of the code is available in LangChain already. What I intend to do is I want to essentially capture these two URLs. Remember, we are using TechnoHealth Solution as the use case here, and TechnoHealth Solution solves, or TechnoHealth Solution essentially, helps doctors and medical practitioners to quickly sift through larger documents. Let's assume that one of the doctors is interested in knowing about lung cancer, and we'll take these two documents. One is from National Library of Medicine, the other one is from Mayo Clinic. These two articles probably will act as documents for us. We'll quickly import the libraries. I have already run this particular code, so I should be good here. And I'm using OpenAI's GPT-4o Mini as the LLM, as well as I'll be using their text embedding model. Let's quickly load the two documents. I think I've done that already, but I'm going to do that again. I'll be using this particular method. This particular method is available in the documentation of the tick token library. You can go through that, but essentially we need this to check what are the number of tokens that we are dealing with. And as you can see, the article number 1, that is the National Library of Medicine. This particular article has close to 43,000 tokens, I think, which is good because I'm using GPT-4o Mini, and which has a much larger context window. And the other article has close to 5,000 tokens. In this particular section, we'll be using the recursive character text splitter. We'll be using the chunk size of 400. You can also use the overlap size. I'm not going to use this for this particular example. We will instantiate the Chroma DB instance, and I'm going to be using the text embedding 3 small model. What I intend to do is I'm going to create the chunks from the documents that we just loaded, and store those chunks into the Chroma store. Chroma store essentially is a vector DB, and store the larger documents, that is the documents, these two articles essentially, into the in-memory store. In-memory store is essentially a key value store. You can use this to store the entire document. All right. I will be using the Parent Document Retriever, which is essentially a LangChain module. And we'll pass the store that we want, the doc store that we want, and the child splitter. Child splitter is essentially the recursive character text splitter object that we created. Once we run this, I'm going to run this again. I've already done that. All right. With this, we have the retriever object instantiated. I'm going to pass the documents that we just created from these two articles, and this is going to take some time to run. We'll wait for that to run. All right, that's done. So I'm going to scroll down a bit. So I'm going to check how is lung cancer cost. And this is the response that I'm getting, which seems to be a decent response. I'm going to say what are the symptoms. I'm going to also try the query, what are the symptoms of lung cancer, and let's see what the response looks like. We'll come here. Sorry. Yeah, so yeah, it's pretty neat, and it's coming from, I guess, this particular document here, which is good. We'll use the .invoke API in the retriever object, and we'll actually print that object. The length of this particular object is this. I'm actually going to print. Let's see what happens here. Yeah, let me scroll down, and we should be able to see the entire document here. Yeah, I think we have the entire document here. I want to ensure that in my use case, but that might not be an ideal use case for me, because in a lot of use cases, I might probably have a PDF or a document or a text document which could have several pages, and I want to ensure that I'm first creating larger chunks and then creating smaller chunks from those larger chunks, meaning I create parent documents. From the source document, I create parent documents, and from each parent document, I create child documents. So we'll still use the same parent document retriever. However, this time we'll be creating two chunks. We'll first create the parent splitter, meaning we'll use the recursive character text splitter and give it chunk size of 2000 characters, and we'll use the child split. We'll use the same recursive character text splitter, and we'll create chunks of size 400 characters. In this case, we'll be creating a ChromaDB instance with the collection name as split parents, and we'll be using the same embedding model here, and we'll create an instance of the in-memory store. It's a LangChain, in-memory key value store essentially. So in this particular instance, we'll pass both the child splitter as well as the parent splitter into the parent document retriever object, and we'll create an object called retriever from this, and we'll again add the documents to this. Let me run this again. Let me ask the same question now and see the response that we get from the LLM. Obviously, the response looks very similar to what we saw. The reason being, remember, the chunk size is exactly what we created in the beginning as well, meaning what is retrieved here in the vector store is the smaller chunks. However, what is retrieved by the parent document retriever is going to be completely different. So let me run the same query here, and I'll actually print both the document as well as the length of the document, and you will probably see that the document is not as big as the last time, and it is limited to 4,000 characters only. But the document size is precise, and the actual document length in this case, I think the character length we gave was 2,000. Yeah, so the length of the character is 19. So the length of the document is 1925 characters, and the document is relatively small. However, it has the context that we need. Okay, now let's look at the object. This is the first document that it is returning. I think it's the same thing that we just saw earlier. All right, let's move on to the next one. I'm going to clear this. I'm going to delete this. I don't need that. All right, so the next thing that we'll be doing is we'll see the quality of response that we are getting from the LLM in this case. We'll be creating a chain, and we'll be passing the same retriever object and the question, the original question, and also the context here. So the question here is the same question: what are the symptoms of the lung cancer? We'll be invoking the chain object, and let's see what is the response that we get. I've already done that particular query, so you'll probably see a similar response. Let's see what happens. Let's see how long this takes again. All right, so I have the response now. The symptoms of lung cancer may include a new cough that doesn't go away. This looks very similar to this. Yes, it looks good. The summary also looks good. However, I'm going to give it a new question. So let me try and find something. How smoking causes lung cancer? Yeah, this seems to be a good question. I'm going to twist this a bit. I'm going to give it, how are smoking and lung cancer related? Let's see what the response is. Smoking, the primary cause of most lung cancers, introduces cancer-causing substances known as carcinogens. Interesting. It has taken this from here. Let me actually see if there is any smoking. All right, tobacco smoking. Yeah, but I think this document probably has a more, it has picked up this particular document because I think contextually this particular document makes more sense. Interesting. All right, as you can see, providing larger chunks to an LLM, depending on the use cases, again, depending on also the context length and the size that the size of the documents that you're dealing with, the response from the LLM will be of higher quality. So if you want to, or if you're dealing with documents which are sort of interconnected or documents which have some relationship in segments, I think this particular technique is definitely going to help you. All right, thank you so much for watching this particular video. If you like this video, please share it with your network and kindly subscribe. Thank you so much.